Hello, everybody, and welcome to unit testing. Got a few people trickling in here. We're going to go ahead and get started in a couple minutes. Thanks a ton for joining. If you'd be so kind to remain muted when you're not speaking, just so there's no background noise, that'd be super helpful. But as we mentioned in the invite, we want this to be an open dialogue. So we're going to kick things off with some introductions, a brief history of zero-knowledge machine learning, and of course, we have a couple of introductory questions, but if you come up with anything during the conversation, just raise your hand, ping me in the chat, and you can unmute yourself and get involved in the conversation. Super excited to be hosting Daniel from Modulus Labs and Alana from Variant Fund, and of course my partner Rand Hindi from Zama, also an angel investor here in Paris. So what I think we should do is just kick off the call, go around with some quick intros. I can start with myself. My name is Kyle O'Brien. I'm an American based in Paris. I have been for the past 5 years and spent the last decade or so in tech, from big tech to startup operator to media, and now as an early stage investor in deep tech here in Europe with Rand. And we kicked off this unit testing kind of media project just about a month ago. We're super excited to bring people together that are focused on intersectional topics across the deep tech landscape and to have meaningful and interesting conversations and bring the dialogue to other folks in the industry. So thanks again for joining. I'm going to kick it off briefly to Daniel to start things off and make a quick intro. Daniel?
Wait, sorry, guys, if you're not speaking, can you mute yourself, please? Thank you. Awesome. Go ahead.
Laying down the law. I love it. But yes, happy to do my intro. Actually, Kyle, I don't know if you've ever seen American in Paris. It's one of the best, greatest of all time Broadway musicals, George Gershwin. Anyways, hi everyone, I'm Daniel. I always say that I read a lot of sci-fi at Stanford. That was my kind of origin story. But I was also educated there, and that's where I initially met my co-founders, fell in love with AI, and then very quickly fell in love with crypto as well, and realized that, hey, maybe there's something interesting at the intersection here. But yeah, I guess I look like I'm 12. I'm a little bit older, so I don't really have too much more to say on my intro. Hopefully, zkML is a more interesting subject than my own story. I'll just end it there for now.
Great, thanks. How about you, Alana? Tell us about yourself.
Hey everyone, I'm Alana. I'm on the investment team at Variant, which is an early stage crypto native venture capital fund. I've been at Variant for about a year now, and prior to Variant, I was at Boston Consulting Group. I was doing primarily private equity due diligences at BCG, but spending pretty much all of my nights and weekends learning about crypto and new sort of economics and business models. And after hanging out on the sidelines for a couple of years, decided to jump in full time. Excited to be here.
Thanks, Alana.
Hey guys, I'm Rand. So my background is actually machine learning, did a PhD in 2007. So before ML was actually a cool thing. And after that, I was running a machine learning company that got acquired. And now I'm running a cryptography company working on something called homomorphic encryption. So I'm also a deep tech angel investor. I like to invest as early as possible in companies building as complicated technologies as possible. So the way I like to frame it is that I invest usually before people even understand what the company is trying to build. So if you guys are thinking about building something very, very hardcore science and engineering, I'd love to talk about it. And so as Cal said, Cal and I have been investing together. Deep tech is a pretty broad space, but the intersection of cryptography and machine learning is something I've always taken to heart. And so I'm super happy to have Daniel here that I've been following for a while with Modulus to actually talk to you guys about it. And as Cal said, also, let's make this a conversation. So Daniel will give us kind of like his view, a brief introduction, and then this is an open floor. So think of it as a, ask me anything session type thing. And Alana and I are here to sort of like, help steer a conversation if needed.
Great. Let's hand it off to you, Daniel, to maybe to kick things off. Just as a preface, really the spirit of these events is, finding intersections and points of tangency between different categories or disciplines in deep tech. And today, really, the focus is around zero knowledge proofs, which is taken the crypto world by storm, and machine learning, which has taken the rest of the world by storm. And we're going to essentially fuse those two topics together. So I think Daniel is probably one of the foremost experts on this subject. He's humble, so maybe he wouldn't say that himself. But tell us a little bit about kind of how you got into the space, what exactly zero knowledge proofs are, and why it's important in this advent of increasingly powerful and accessible artificial intelligence and machine learning. Why is it important to hold these tools accountable through zero knowledge cryptography?
Yeah, for sure. Yeah, and I was mentioning this earlier. I don't have any slides, so I'll just speak from the heart. The story of zkML, at least from the Modulus worldview, obviously starts with the Modulus story, and our story starts with very simple, an experiment. At that point, when we first started the company, we had just decided to not pursue our PhDs at Stanford and instead spend our time messing around with all this crypto stuff that's happening. Had zero skills in terms of discerning signal from noise by looking at Twitter, but we could read papers. And so we read every paper that we could possibly get our hands on. And very quickly, all the academic work, as well as the applications around zero knowledge cryptography, really kind of spoke to us both as kind of math nerds, as well as just kind of folks who were looking for kind of that inflection, right, where that technology was getting much better, much faster. And it was so clear to us that ZK was kind of where that action was happening. And so at this point, we really only knew AI from our academic training and ZK from the papers we were reading. So back to that experiment, we thought, how hard would it be to actually encode a machine learning algorithm, even a simple one, in a zero knowledge circuit, right? This is something that no one had really done at the application level before. And so that kind of led to us stumbling into what became the world's first on-chain AI project. A very silly project. It was a low trading bot, 70,000 parameters, just trying to guess at whether ETH prices would go up or down tomorrow. But what was cool, of course, and this is really the kind of the thread that connects all of zkML, is it fully committed to this paradigm of tamper-resistant autonomous execution that is provided by this like blockchain network system. And so even though we told people, as an illustration of that feature set, to not put money into this non-performant trading bot, which didn't even have a call function, so like Modulus team couldn't even bring the money out afterwards. Folks on the internet just started sending dollars to keep Rocky alive, and the bot ended up trading for over a month, right, before it lost all its money, which makes sense because it's a very small model. We did not crack the crypto markets, but it was the seed of this idea, obviously, what we now know as zkML. But for us, more specifically around, okay, if we could do kind of something interesting here with a very small model, what would happen if we brought really performant models on chain, much larger ones, the ones that are getting all the headlines, the Stable Diffusions of the world, the ChatGPTs of the world. That was about 8 months ago. Since then, we've been on this journey of trying to figure out exactly what are the technical unlocks we need to bring models on chain. And obviously, there's a lot to get into in that journey and all the projects we've done so far, as well as our overall technical worldview. But before we dive into that, which I think will be the protein of this conversation, maybe just a quick refresher on what zkML is specifically, at least kind of our definitions for it, so we can establish some common language, and then we can obviously always challenge the boundaries a little bit. The way I like to think about it is to break it apart, right? We'll start with ZK, the first two consonants. They're just very exciting letters, I know, but at least with zero knowledge cryptography, and this is probably, folks already have some degree of knowledge in this. It was actually a tech invented back in the 80s as a privacy or a compute integrity technique. It's the ability to effectively convince a counterparty that you had done some math correctly without revealing anything about the underlying math, right? And kind of the canonical example that people like is like a Where's Waldo puzzle, where I want to know that Kyle figured out where Waldo was, but Kyle doesn't want to show me where Waldo is. And so potentially what he could do is cut out Waldo's head. It's very graphic from the puzzle. Show me Waldo's head. And I'm fully convinced that Kyle could not have possibly found Waldo if not for the fact that he's literally holding his head, but I don't know where Waldo might be. it's kind of silly, but what's of course really odd is that there's this corollary property of zero-knowledge cryptography known as succinctness. And it kind of shows up a little bit in that previous analogy where, if you think about it, it's really easy for me to check that Kyle was holding Waldo's head. It's actually much easier to do that than to actually find Waldo or watch Kyle find Waldo. And so, 30 plus years after the invention of ZK as kind of an academic technique in the realm of security, blockchain networks turns out to be an excellent application of this technology because compute is really expensive on blockchain networks. And of course, it's very easy to instead do the compute off the chain, but then use the zero-knowledge cryptography process to prove the correct execution of that off-chain compute, thereby only rendering the kind of on-chain responsibility to the verification, right? You can also think of like a Sudoku puzzle, which is very easy to check, but much harder to actually solve. So this kind of combination of compute integrity as well as succinctness has formed kind of the foundational paradigm or the foundational building blocks of today's kind of blockchain-based context for ZK. And of course, there's also a privacy property, but we can dive into that maybe in the meat of the conversation, because it's actually underutilized, I think, in the blockchain context. But nonetheless, that's ZK, and obviously a lot to unpack there. The second set of letters is ML, machine learning, right? This is the process, and obviously everyone kind of has at least a visceral, I'm sure, exposure to this, but of exposing an algorithm to a ton of data, oftentimes labeled, sometimes not, so that the algorithm can actually pick up the capacity to semantically differentiate and classify new data, right? This is kind of like a robot approximating human behaviors and human decision-making, which is just conceptually totally wild, right? It's like this super expressive technology. And of course, Ran mentioned that he did his PhD, I think in like 2007 or something. Right after Ran wrapped that up, GPUs became available, which brought in the modern paradigm of deep learning. Turns out if you throw even more compute at that like process of algorithmic learning, there are just like emergent performant properties. And of course, we're continuing to go down that trajectory. And now we're stumbling into LLMs as the next big architectural milestone. But from vision networks to classifiers to natural language models, there's a ton of really exciting ML work that really has never been applied to the blockchain because of that kind of compute resource limitation, right? So that's machine learning. And of course, again, a lot to unpack there. As you can imagine, I kind of tease this up a little bit. The marriage for Modulus and for all the folks, I guess, excited about zkML is specifically around leveraging the ability for zero-knowledge cryptography to bring really expensive compute, effectively compress it, and then elevate it up to the security standards of the chain so that you can integrate it into your smart contract and bring that exactly that kind of behavior set to the machine learning operation, right, or that process, thereby bringing AI up to the security standards of whatever smart contract you're integrating that into. So that is a super, super succinct crash course into zkML. There are a ton of ways of kind of reorienting those two topics and what are the intersections. But I think the last thing I'll say, and this is the end of my tirade, I promise, is the analogy that I like, right? And if there are any AI practitioners in the crowd, y'all would probably hate me for this, for kind of simplifying things. But nonetheless, this is how I like to think about it. I like to think of a machine learning algorithm kind of like a factory, right? So you can imagine like the architecture of the algorithm is like the different machines in the factory. The parameters or weights of the algorithm might be the settings on the machines, right? So like the knobs and the levers and where they're set and so forth. And during the training process of a machine learning algorithm, it's as though you're shifting machines around and tuning the levers and turning the knobs until everything is just perfect. You pass in oak and you get out on the other side of the factory, an oak door. You pass in, I don't know what other kinds of wood, mahogany, and you get out a mahogany door, right? The machine is perfect. The factory is great now. What ZK then, in the context of zkML, is imagine coming up to the factory and just dropping a giant cage on top of that factory, right? So everything is frozen, right? Oh, and by the way, you pull out the operator. That's really key. So the operator can't go into the factory and change any of the dials or bypass some machines or just feed in, their own blueprints. The machine itself is now kind of static. It's frozen in time, almost like a smart contract. all it can do is continue to take in oak and put out oak doors, take in mahogany and put out mahogany doors. And the operator is kind of like banging on the cage, desperate to get in. And we go, no, you cannot get in because of the power and the bronze of mathematics. Anyway, so that's zkML according to Daniel. Please don't tell anyone else about this analogy. It's highly IP protected. I take royalty every time you mention it. But yeah, that was Crash Course, Kyle. Please. Open it up.
That's an amazing introduction, and so I appreciate all the context, and it's coming from someone who's working in this space day in and day out. A couple of points that I come away with is, I mean, there's a lot to this. I mean, first of all, it's a fairly abstract concept. You get down to the deep math, it becomes a little complex. You try to bring it up to an analogy level that helps us understand it a little bit more. There are a number of areas where I see this being effective or useful, and I think a good way to steer the conversation is around the application layer or the use cases to make this a little bit more concrete. So I'm thinking about things like privacy. I'm thinking about things like accountability. You mentioned scalability with ZK rollups, for instance. So actually, I'd love to kind of hand it over to Rand quickly, because Rand, I know that you posted an article recently about some of the very specific applications or use cases around zkML that you're excited about. And I know at Zama you focus day in, day out on privacy. So maybe we could talk a little bit about the implications for privacy in the context of zkML and how you think about how you think about it from your perspective.
Okay, so yeah, I think you're referring to the post I just did on my blog, right?
That's right. Yeah.
And I think it wasn't specifically about zkML, it was more about cryptography and machine learning.
Yeah.
And the point I was trying to make is that when you think about AI safety in general, it's not just about preventing AI from killing people and things like that, right? It's not just about alignment. It's also about trust. And for me, trust is trust that the content you're seeing is produced by the person who is actually in the content, right? So that's something easy to solve with cryptographic signatures. So basically just have like some kind of crypto wallet that signs all of the content you publish to prove that you actually created the content. The second trust issue is around privacy. So this is what my company Zama is working on with homomorphic encryption, where you can basically have encrypted processing so that the user doesn't have to reveal anything to the server during the processing. And then the third one is zkML, which I believe solves the issue that you have to trust whoever's providing a service, that they're actually doing what they say they're doing. And, usually you kind of trust service providers because, you pay them, there's a contract, and then, if they don't do what they're supposed to and get caught, well, technically you can sue them. But if we're talking about automating most of the world, you want to make sure that people haven't tampered with those AI models in order to poison them and make them do things that they're not supposed to do. A good example is like a self-driving car. You could inject some specific changes to the model that would make the car crash in very specific circumstances, which would be an incredibly good way to assassinate someone if you wanted to, right? So how do you make sure that the model that's running is actually the one that the company claims has been built and the people audited in these things? And this is where I think, beyond blockchain, where I think zkML can come in, it's a way to prove that the machine learning model was computed correctly. And so in the case of blockchain, it basically gives you the ability to do the computation off-chain and put the result on-chain. So you don't actually care about the ZK property in this particular instance, actually. You care more about the validity part. But I think this goes way beyond. For me, zkML is a technology that's going to be used in cloud computing and pretty much everything.
Maybe I'll hand it over to you, Alana. What have you seen in the zkML space from an investor standpoint? How fast is this technology developing? My understanding is that it's growing quite quickly to the point where even kind of generalist developers are starting to have access to play around with these tools. You don't have to be a subject matter expert anymore. What are the implications for growth in this space? What other companies, aside from Modulus Labs, have you seen that are experimenting here, and why does it matter?
Yeah, it's a really good question. So I think whenever you have two sort of deep tech fields that are advancing at the same time, it's really interesting whenever you start to see the convergence and overlap. And it sort of just leads to an explosion of like creativity and innovation. In the case of zkML, it's machine learning and then zero knowledge that are both advancing at exponential paces. Within the context of crypto and blockchain in particular, I think we're really excited from an investing standpoint because what is machine learning really good at? Solving complex optimization problems. What are humans really good at? Expressing objectives. So you think of when you look up something on Google, for instance, you say like, I'm interested in like looking up dinner restaurants in Paris. You don't necessarily know the complex optimization of how to go about that, but Google presents you a set of options and they sort of scan all of the data in the back end. We don't yet have a great version of that maps to blockchains. And I think that's where we'll start to see zkML applications come in. So you can think about something like this in the context of preference expression. User wants to swap or wants to buy, say, 10 ETH via a DEX on chain. They don't know what chain has the lowest price. They don't know what DEX has the best pricing. If you have verifiable AI agents or machine learning models that can compute that off-chain, do all the complex routing and figure out the best route for that, then you can start to bring that on-chain and create a much better user experience. You could extend that to sort of any objective that a user wants to complete on-chain. Some people are calling this intents, some people are calling this programmable transactions, others are just calling it preference expression, but I think that's one of the biggest unlocks. Anywhere you have like complex optimization problems, machine learning can help solve that in the context of blockchain. In terms of, sorry, I missed that.
I was just kind of rebounding what you said. I think like, preference recommendation systems, like we have those in the real world, like the non-blockchain world, right? So like it's crazy to imagine that we can continue building blockchain apps that doesn't use all of like the advanced recommendation and sort of like personalization features that we're using every day in every single product today, right? Like think of like a blockchain social network, for example. There is no way this can ever work unless there is some kind of like algorithmic filtering of the content you're seeing, right? So like, I totally follow you on that. I think it's user preference and personalization is a very big use case for that.
Definitely. And so then in terms of what we're seeing in the space of developers and founders and builders, Modulus Labs is obviously one of the knowledge authorities in the space on this, and they've been providing a lot of great research and I think educational materials. Jason Morton, who's working on zkML, I think he pronounces it Ezekiel, but I'm not quite sure. He's also been doing a lot of great work there, sort of from the public goods standpoint and developer tooling. I believe Axiom may be working on some things. This is all just from public readings and public content. But it does seem like there's a lot of interest. And I think anytime you have a flood of developers enter a space, the technology just compounds exponentially.
We've got a question from the audience. Vishesh, I'm asking you to unmute here, so you should be able to speak momentarily.
Sure. You're talking about how AI ML specifically is like pretty well proliferated throughout Web 2 applications, and it's just kind of a standard part of like the user experience for any site, any app you use. And most users aren't really aware of this, but like pretty much every application uses some sort of recommendation engine. And like, I think this is, in my sense, probably where we move with ZK as well. It's like, there's no reason pretty much every application can't be auditable at the end of the day, at least for things that have an on-chain component or a like standardized off-chain compute component. And I think this is where the coprocessor stuff, you mentioned Axiom comes into play as well, because like theoretically any ML application, any on-chain compute, any recommendation engine, any like preference expression system, intent matching, like all these things can be auditable. And it's actually just kind of a faster, more efficient version of what we do in Web 2 anyway, because you trust somebody to do something correctly. You later find out they didn't do it correctly. Maybe you sue them, maybe you ask for your money back. Like, this is just kind of speeding up that cycle with ZK proofs as I see it. So, this is where I actually, maybe it's a spicy question for this group, but this is where I question sometimes how much there is ML specific proving versus kind of more generalized proving that is applied to ML because it's a good first use case.
Yeah, it's a good question, Rashesh. I'll start by saying, actually highlighting something someone in the comments mentioned. I think it's Tejas, that as a really key component here is the cost, right? Specifically the cost of like unfaithful ML. It is still more expensive, surprisingly, to do really sophisticated cryptographic operations on top of naive computation than it is to not do that. And so there's always the question of what are the stakes, right? Like if it's a social media feed, is it that it's not political, or it's that it's doesn't have like negative attributes like racism, sexism, whatever, right? And obviously that's a little bit eye in the beholder and all that. But the reason that's relevant is, while that's the cost of unfaithful ML, the other side of the seesaw is the cost of those cryptographic operations. How expensive is it to do a ZK proof for an LLM, right? And Vishesh, I think this is where like the Modulus worldview is in direct opposition to what kind of your instinct a little bit. The cost is enormous. It is really, really substantial. And this is kind of like a dirty word, cost, in the context of ZK. Nobody likes to talk about it. Modulus exists to talk about it. Specifically, if you take any model, right, and this is a simplification, the current overhead, right, with the state of the art, I'm not even talking about using an L2 like ZK Sync or Starkware, where you need to additionally, emulate memory registries and all the VM operations. I'm talking just about taking a really great proving system, customizing it to the extreme, right, making it perfect to the metal for machine learning operations, or at least the algorithm you care about. The overhead is about 1,000x, right? And that's like pretty optimistic. And so, if you do $15,000 in compute costs per month, as many of our customers do, and I come to you and I say, hey, we're gonna 1,000x that on your machine learning workload, they're out of a business by day 2, right? Like realistically. And so I guess to more specifically tackle the point about taking generalizable proving systems and applying them on machine learning algorithms, my ask is, or my question is, do we think that by making ML accountable, we 1,000x value add for all of these customers that we have, for all of these services? And you can say, oh, but the 1,000x is going to come down, just hardware acceleration, there's this, there's that. A step change is required in Modulus's opinion, my opinion. And, we are obviously part of that kind of sea change, right? But very earnestly, I do think that as we bring that cost down, the design space expand rapidly. And at least these generalizable prover approaches will always have the big scary challenge of having to prove other things as well that are not machine learning. If the crowd is curious, I'm very happy to go into why by specializing on machine learning, we can make the proving system much more efficient.
Yeah, I was going to ask that. So what kernels can you cut? Like how more efficient does specialization get you?
Yeah. The analogy I like is like, maybe like taking a generalist proving system and customizing it for machine learning is like taking a school bus, which can go everywhere, and strapping on rockets. Super cool, super down. You got a rocket called GPUs. You got another rocket called, some cryptographic techniques to speed up specific operations. What we are building in Modulus is a bullet train, right? It doesn't go left, it doesn't go right. It follows a track, but it's exceedingly fast. And specifically, it's not because Daniel or the rest of the Modulus team is like the smartest people who have ever walked the earth. I wish that were true. Maybe one day, unlikely though. It's just because the problem statement's much easier. And I'm going to say a couple kind of controversial things. First of all, machine learning in terms of the actual mathematical operations is very simple. It's just massive, right? By, I guess, a bucket of compute, it's like 97% map mole on a relatively large model, and then a handful of nonlinearities. That is what an AI algorithm is. And these primitives, map mole, ReLU, batch norm, these specific modules are shared across most of the popular AI architectures. So to actually answer your question, Rand, we take advantage of that pre-selection, right? It's like a down-selected, smaller set of mathematical operations for a class of problem which is highly repetitive, highly structured, and therefore, from a ZK proving standpoint, from a circuit building standpoint, we can make massive reductions in overhead and make sure that we can bring that design space expansion to market much sooner. Yeah.
Can you tell us a little bit about, because you did another experiment, you talked about Rocky, the trading bot, and I think, machine learning has been used in finance for a couple of decades now. Actually, when I was doing my PhD, we used to make money doing consulting for hedge funds. They were trying to get their heads around what this whole AI thing could do for finance. Now, obviously, everybody does it. But the other thing that you also experimented with is gaming. And I think, this is another big area that I think like machine learning is necessary for in blockchain, is basically blockchain games. Like, think about any game you play on your console, unless you're playing against a human, there needs to be some AI playing, the other side of, whatever you're doing, right? So how would you see like zkML enabling more of like the blockchain gaming space?
Yeah, it's a great question. And games are such an excellent arena for experimentation for these algorithms before maybe you bring them into specifically financial applications as well. I think I want to make this really, really specific. So I'll use one of our favorite design partners, AI Arena, right? So this is a blockchain-based game where AI agents kind of compete with each other asynchronously, autonomously in this like Street Fighter-esque, 2D avatars fighting against each other. And players train their own AI models. They're represented by NFTs. And of course, after that point, the models are dynamic. They continue to learn from the matches that they engage with. And the game is 24/7 forever because, it's blockchain and all the good properties that comes from that. And we really like the AI Arena example, in part because the game is fun. That's like a non-trivial challenge. And the second part, of course, is that, and maybe to the point of scale again, these are 3-minute matches at 60 frames per second. By my accounting, that's about 20,000 AI decisions that needs to be proven per game. Because of course, especially for tournaments where players are staking a lot of dollars, there could be an incentive for AI Arena to put their thumb on the scale or anybody else to tamper with the results. And so to actually verify all of those AI decisions would be absolutely untenable today, right? But we expect to support their first batch of kind of the final stages of their tournament early next year. Because
does it have to be proven in real time? Can't you have some kind of like delay for the proof to arrive before the prizes are distributed or the round advances or something like that?
100%. Yeah, for sure. But of course, that puts a constraint on the construction of the game space, right? Maybe that constraint is acceptable, right? An AI Arena can say, look, your prize pool will just be settled by the end of the day. We're going to batch everything up, prove it in giant blocks, digest it by on-chain verifiers, and then make sure that, we take the lowest hit to our margins as possible. And that's like an amazing like business level decision or a product design decision. But of course, the longer your proving takes, the more expensive it becomes. And of course, the more constraints you have to put in the game design world, right? And so I think at today's kind of state-of-the-art proving stack, we can barely support this like asynchronous proving. Again, our opinion is that we really need a step change in the reduction of overhead.
Do you think hardware acceleration plays a role here?
Mm-hmm. Yeah, for sure. I mean, this is, I spend a non-trivial amount of my time talking to every single ZK hardware acceleration company, right? In part because I want to make sure our tech is plug and play. And the other part because I think it will be, again, a step change in the right direction. The caveat is that we can't for sure know that hardware acceleration is always going to be the right choice for all of our customers. One of our design partners is WorldCoin. In that case, the prover is running on your mobile phones, the client's edge device, oftentimes 32-bit Android phones with like 2 GB of RAM. So our prover needs to work in that kind of hardware environment. And by the way, everything I've mentioned about overhead, imagine that now on an Android 32-bit phone. But also, of course, for the premium, high volume customers that can afford ASICs and GPUs and even more exotic silica, then obviously we want our provers to be really performant there as well. I guess that the insight for us is that specialization will always be the right move whenever you have scale in either the size of the model or the volume of inferences being made.
Can I ask a somewhat layman's question here about these proving systems? So we talk about a prover, and I understand the reason or essentially the mechanics, but how does this manifest? If we go back to the example before of running a Google search, we know there's an algorithm, some decision engine going on in the background. Generally speaking, I just trust that Google has my best interest in mind, and there's nothing malicious going on in the background. So I see why a prover, an external prover to validate this could be useful. When we think about the blockchain gaming example that you gave, or when we think about interacting with some sort of AI agent and validating that they are indeed running the agent we think we're interacting with, where does the prover sit? I mean, is this Modulus Labs operating as an independent party? Is this a tool that they integrate into their product? Why would a company actually want to integrate this into their product if it does cost quite a bit and have implications for delivery and speed? And how does that fit into the whole picture of like a trustless internet? I have trouble wrapping my head around that, exactly where this fits. So maybe kind of like some sort of diagram or something would be useful.
Yeah,
yeah,
100%. Yes, and okay, so there's I'm going to start by saying again something very controversial, which is trustlessness is in practice not a very binary thing, right? Is like Uniswap v3 trustless? Is Arrakis and Gamma, which is on top of that, extending that promise, so on and so forth, right? And of course, the kind of silly sleight of hand, which needs to happen at the very bottom of the stack, right, in terms of the core consumer behavior, is that I choose something like Uniswap because it's on-chain, because it's trustless, because I know it's probably safer, because there's people who can audit it, because it's easier to trust, right? That's like the consumer journey, right? And so usually when it comes to talking to our customers about where is the prover, is it by Modulus, is it on AWS, is it on G Cloud, is it on your phone, is it in your own trusted execution environment? Not sure why, but let's say, it always starts with kind of a higher level product design question, which is, why does your customer care? Like genuinely, right? And by the way, if they don't integrate us. zkML will always be a premium, right? This is the thing that people really need to, I think, like take in and internalize, because it took me so long. We are selling organic bananas. We're not selling regular bananas, right? Strictly speaking, it is kind of a more expensive product, right? And so the trustlessness needs to be justified, and people need to care, right? So to actually tackle that question more specifically, it just depends on the customer, which I know is kind of a cop-out right now. But the fact of the matter is Modulus is an 8-month-old company. We don't really know exactly the replicatable use case category, what that looks like right now. What we do know is that it's probably, in terms of justifying a business case, going to look like high volume or high sophistication. And so we are very proactively doing that not scalable thing of being super white glove, super bespoke, going all the way on integration, actually building complete projects. This is crazy, but we actually verify our proofs on real blockchain systems and post those proofs on chain, so that we can understand the exact pain points and how to build, services that actually make sense for end consumers. So yeah, kind of a cop out, but also the honest answer.
Yeah.
I think we have a couple of questions in the chat. Guys, feel free to just speak up. I think it's easier than the text version.
So one thing I would say is my earlier question is a bit of a straw man, because I wanted to hear you talk about specialized provers. But I mean, I do think that it makes sense to have specialized provers for different use cases, ML obviously being one, but it's not just even that. I think that's the wrong level of detail. Like, it's even like a specific model or a specific type of circuit. So it actually gets pretty niche, and I think like there's a whole fun logistic world we could talk about that would probably bore a lot of people about like which proofs, which circuits, where do they come from, who actually accesses them, and that's a whole design space, right? But I think for a given problem set, for a given use case, there will be some mix of that makes sense, because it's just reducing the cost of auditability in my mind. I think it's a little bit of a, again, straw man for people to think, oh, we're going to have an API that's streaming, millions of transactions a second. We're going to try to prove each one of those, and then we're going to go back and like check every proof. Like, I don't think that's quite reasonable. I think that's what a lot of people think of, and then it doesn't make sense to them. So I think one thing, yes, the hardware acceleration is good, but I think it really also depends on the compatibility of like your proof systems to the hardware that you're using. And I think we're starting to see, I think just now, a little bit more expressiveness in terms of what kind of a proving system can you construct for which hardware cases. And I think some of the GPU compatible stuff recently is pretty interesting, especially since there's a huge overlap of like the compute resources that are used in AI is like, you know, a lot of GPU based stuff. So yeah, I think maybe batching is an interesting topic, right? Like to what extent, you know, somebody asked, where do you care about proofs? Well, maybe actually your users don't care about proofs, but just the fact that the system they're using is auditable by someone at some point is a net improvement over the existing system. You know, I don't think everyone's going to be a watchdog. Every user is not going to be a watchdog. Like I can probably tell you that with a pretty good probability. But the fact that somebody can be a watchdog on their behalf and that that's relatively trivial to do, I think gets you most of where you need to go. But yeah, that and batching, I think, are two interesting topics. Take your pick.
But I guess in this case, you're talking about general zkML, because if it's on a blockchain, the smart contract is the verifier, right? So it's the watchman by design, right?
Assuming every transaction is on chain, yes. But I think
Sure. Yeah. Okay. Yeah.
I think
the catch is, sorry.
Yeah, go on.
The catch is you won't ask for the ZK proof for every inference call, because inference calls are like going to be made all the time, and you want inference calls to be not expensive. So you kind of randomize your ZK proof ideally. You randomize the fact of asking for the ZK proof randomly, and that kind of is the watchdog that I think Vishesh is talking about.
Right, I see. So you have like some kind of like random sampling of proofs. And so you have a probability of catching like a fraud. Basically.
Yeah, because otherwise every inference, if it's accompanied by a ZK proof, that's an overkill, because most ZK technology is around rollups and, you know, where you are proving things which are in a batch already in some sense. So batching the ZK proof, batching what you prove in the ZK proof is kind of a reasonable design pattern to think about. And the verifier, of course, is on chain and it's constant sized and constant, whatever, all the good stuff. Maybe I'm wrong, and Daniel has a different opinion. I think he has something to say.
No, I mean, I think, so I totally understand the instinct, right? And by the way, you can extend this kind of more probabilistic thinking all the way down to the proofs themselves. Why prove every single step in the computational trace of a machine learning model? Super, you know, it's like very repetitive. Most of the stuff is like pretty obvious. And like AIs, they're squishy. They're not like cryptography, right? Like there's like some error that you can handle before the model catastrophically self-destructs. I guess my challenge to that is, and by the way, we prove everything, even in the batching case. The ZK runs for every single circuit, every single step in every single computation, and the verifier takes account of everything. When we index everything, Merkleize everything, recurse everything, so that the actual on-chain Merkle, like a recursive proof, dovetails to the off-chain batch AI inference of every single step in every operation, which sounds very redundant and very annoying. And I wish it wasn't. The reason, at least from kind of our standpoint, is very simple, which is if I omit the proof of a single weight from a single inference run, if I'm an adversarial kind of agent, I would just hammer that weight. I would, multiply that weight by 200x, right? And it would totally destroy the kind of preceding computation. So that's like one scenario that we're very, very mindful of, because, given a motivated enough attacker, that's a vector that they're definitely going to take advantage of. With that said, though, and this is maybe back to this whole thing as kind of a product design question. If you have a pretty good authority on randomness, probabilistic random challenges could radically reduce the overhead, right? Instead of like literally verifying every single computation. It just depends on the use case. It depends on how motivated that attacker is. So there's like the academic instinct in me, and then there's like the product design, like business instinct. I think the quote unquote correct answer, since we have VCs in the crowd, is we'll be the line, right? You pick where you want to be on that spectrum, customer. But the kind of earnest answer is we want to make sure that we're the best in class, heads and shoulders above in every league, no matter where you want to be on that
line. Katrina, I had a question as well.
Yeah, I'll just ask directly here. Well, steer the conversation in a slightly less technical angle. Would love to learn how the three frontier tech, you have the AI/ML, you have ZK, and Zama is obviously the ringleader in the homomorphic encryption. What would be the use case and kind of in the supply chain if you have to work together? Who would take what? If you have example.
So I think zk and FHE are two, like, they solve two different problems. So zk, there is like the zero knowledge part, which actually hints towards some privacy part. But what I think is that the interesting part of zk is the verifiability. I see it way more as a way to prove that you've done something rather than a privacy technology. And FHE is a privacy technology, but it doesn't prove that it was computed correctly. So what you really want are, is verifiable FHE. So, we will shorten that to zkFHE, even though the zk probably be redundant in this case, right? You wouldn't need it. That would be the ideal scenario, right? Whether you apply to AI or to rollups or to any other type of stuff. Like, my bet is that in the future, every single piece of, I would say, like, everything you use online will be encrypted end-to-end with FHE. The response will come back with a proof of the computation's correctness and a cryptographic signature that guarantees that, the person is really the author of, the response and things like that. And really, blockchain is just a great test bed for doing that before you bring this to, Web 2, which is infinitely bigger in terms of, like, computation costs. They're just, part of, like, solving the trust issue, I think.
Super helpful. And just a quick follow-on question there. In terms of go-to-market, I mean, to Daniel's point, it's a spectrum of willingness to pay for this privacy, for verifiable compute. So what, in your mind, or this can be a question to, Daniel as well, will be the first batch of customer who would pay money for this?
Yeah, I guess I'm happy to give it a stab. This is my every single, like, waking moment, right? Answering this question. Like, frankly, if we don't find a robust ecosystem of customers, Modulus should die and the business should go away, right? Which,
Daniel, don't do that.
Yeah, of course. For deep tech people, it's like unimaginable. Like, what do you mean? The tech is so cool. I'm sure, like, when lasers showed up, they said it's a useless technology. And, I guess our job is to make sure we're building a laser, right? Or the laser, as opposed to something maybe more frivolous. I think that the good news is that we have paying customers. We have paying customers who are paying us today. And by the end of the year, Modulus alone will be doing millions of AI proofs every single month. I just know that is going to happen. I don't know if, the year after that, we'll kind of continue to see that go up, right? Currently, the record holder, by the way, in terms of number of AI proofs per month is held by Modulus. Although, to be fair, we're the only ones who are currently on the record board. So maybe that's not so fair. But nonetheless, our early customers, our early use cases, kind of what you expect. They are, folks like WorldCoin in the identity space, right? In terms of wanting private biometric authentication on client end devices. That's like one whole bucket of like behavior set where, like, the prover goes to the user and the analysis happens there. And then there's a whole other set of use case behaviors, which is like DeFi customers, like Spectral Finance would do a credit scoring, right? And we'll be doing that with them to verify that the actual the credit score you get is consistent and never tampered with from the ones before the ones after, right? All the way to gaming use cases like AI Arena, to NFT use cases. Our first zk NFT, so a provable provenance for machine like artist output, will be coming out in like 2 weeks, right? And so there's like a lot of different lanes that you can pick. Our job as a business is to figure out, obviously at a base level, kind of where the research is most promising and kind of continue to sail down that direction, but also map that progress, that inflection, to what the market cares about today and tomorrow, right? Making sure that we can be that, dynamite kind of 1-2 punch between both really strong academic leadership, but also really strong go-to-market, really strong business partners, a really premium kind of, product, right? With a capital P. So that's how I like to think about it. Yeah, hopefully people keep paying us. In a bear market, I take that as a good sign, but we're always a Trojan horse for a better company. So talk to me tomorrow. Maybe I'll have some new ideas.
There's a couple questions in the chat about commercialization and what it takes to. Sorry, go ahead, Rand.
I was just going to say, there's a few questions about FHE in the chat. Let's just keep the conversation today about zk and machine learning, right? We're probably going to do a session on FHE at another unit testing episode. So, you guys should definitely sign up and, come to that. But let's stick to the zkML stuff for today, if that's okay.
Yeah, maybe I think this applies broadly to both categories. We can focus on zkML here, but the path to commercialization, what does it take to get zkML? And this is something I'm sure, Daniel, you think about, day in and day out. Alana, this is probably something you think about when you're, running due diligence on a deal. How do you think about, I guess it's a two-part question. I'll go between Alana and Daniel, and Rand, you can chime in as well. What do you think from a technical perspective is what gets this over the line? I mean, typically you throw a bunch of R&D, a bunch of smart PhDs in the mix, try to make things, better, faster, cheaper. From an investor standpoint, you think about that R&D phase, the engineering phase, and this inflection point, after anywhere between 2 to 5 years where, the company can grow exponentially. How do you model that out in your head as an entrepreneur, as someone who's trying to bring a product to market? That's for you, Daniel, and I suppose you as well, Rand. And then Alana, when you're evaluating companies, what do you take into account when thinking through, the go-to-market journey and making these viable products that in the end end up becoming viable business models?
Daniel, do you want to go first?
Sure. I guess Kyle, could you condense that question for me? My like Twitter thread brain lost track halfway through.
No, that's okay. So I guess what I'm thinking is when you're thinking about bringing a product to market, especially in the deep tech space, there's always an R&D phase. You need to solve the science problem, then it becomes an engineering problem, and then it becomes a scale up and commercialization problem. So where do you see zk and zkML at the moment? What kind of part of this phase is it in, and what are the time horizons? What's necessary to get this to a point where it becomes a scale up business?
Gotcha. Yeah, and I think the reason Alana teased me up here is because yet again Daniel's here with the hot takes. I'm currently with the team who is begrudgingly doing this with me, doing a pre-mortem on not just Modulus but zkML as a category, right? And kind of the headline will be "Who killed zkML?" And I think we don't have the full answer to that question yet. I have a couple of guesses, but it starts with I think a lot of dishonesty, maybe, or maybe not intentional, but like aspirational dishonesty about what the technology is or isn't, right? And what it can or can't do, and how do we get there? Look, I would love to tell you, Kyle, the moment you add zkML to your service, the moment you surrender the power to secretly manipulate your algorithms, right, on behalf of your customers, always, of course, you're going to go home, your spouse is going to be more beautiful, your kids are going to be more educated, more disciplined, you're going to have a better shot at making a lot of money on the stock market or the crypto markets. But it's not true, right? That's not true. And we have folks, again, I don't want to maybe upset too many folks out there right now, but saying that they're proving ChatGPT or GPT, and you look at the proofs and you're like, man, that's a very big proof. That picks up like half the Ethereum blockchain. Or, oh, I don't know if I would, spend a week or even a day or even an hour renting a $4,000, $5,000 plus machine from AWS, of which they only have a few, in order to run, a proof on an LLM, whose quality maybe isn't not so good. I say all that to say that this is why we focus so much on cost, and so much of my time is spent, unfortunately, on readjusting expectations for our customers, being very sober and being very practical. It will get better for sure, right? No question about it. But there will, it's physics. Like, we see the chessboard in front of us. I can tell you that we're all looking at the same set of equations and techniques. And so, the TLDR in terms of how do we actually build a robust business that, God forbid, has an impact for people and makes a positive change in the world. And the crypto values of verifiability actually goes beyond just the 3,000 developers currently thinking, right, in crypto. I think the answer comes from being very sober, being very, very specific, and moving very concretely to build complete services, complete projects, actually realizing the pain point and responding accordingly. So you will not see big flashy headlines from us that at least, doesn't vaguely dovetail into the work that we've actually done.
Right. Alana, do you want to give us the flip side of that coin?
Yeah. So from the perspective of an investor, what we typically look for is first of all, it helps if the entrepreneur or founder has in mind some clear use cases or at least inklings of like where this may be useful or why users may want it. I think like you could look at Daniel, for instance, in Modulus Labs. The fact that they have a few use cases already in production at such an early stage in the technology, I would say is a really promising sign. But even if there aren't use cases directly in production, especially again, early in the convergence of two really important technological curves, making the technology as easy to use and play with, I think, is incredibly important. In the early days, what we look for entrepreneurs to optimize for is ease of use and the number of developers that can play around with your tooling. I think it's really hard to predict, like, what is the killer use case? And does the world today look the same as it's going to look in 12 months, 2 years, 3 years? The answer is no. You don't know, like, how that may change the landscape for developing applications. So what you want to optimize for and what we look for founders to optimize for is just making it as easy for new people to enter the space and as easy to crack as possible. One other thing I'll add is that I think zkML in particular has a lot of product market fit with blockchain applications in particular. In the world of blockchain by design, there are sort of less human arbitration mechanisms. Everything sort of runs autonomously. That means that auditability is especially important. So I gave the example of Google search earlier. I don't really care if like Yelp gets ranked a little bit lower when I'm looking for dinner spots in Paris. It is not a high stakes environment. In blockchain, everything by design is a little bit higher stakes. So that auditability aspect of zkML is especially important. And so I think whenever we see something like that, where there's just sort of inherent need or user desire for this, it always gets us really excited.
Really well put. I think we are coming up on the end of the hour here. If there are any final kind of closing comments, thoughts, maybe questions that are coming through that we wanted to cover, that would be great. But I do want to be conscious of our time.
Just a very quick comments. We have a lot of discussions around the utility, around the complexity. But like, I think, there is also something important when people adopt a technology is that they just find it really cool. Like at the end of the day, it's a cool technology. It's something that's actually fun to use and it's nice to look into. And, something that could do the same thing, but that would be boring or terrible to use would not get as much attention. So I think, we shouldn't forget that like a part of the adoption of the technology isn't necessarily driven just by what it can do today, but also based on whether people like working on it. And, I think zkML is one of those things where people are actually generally excited by it, even if they're not yet sure yet where this is going to be used eventually. What I like to tell people is you need zkML to put machine learning in blockchain applications, and thinking that blockchain is the only space that wouldn't use machine learning is crazy. So, if you agree that blockchain will use machine learning like everything else, then you need zkML, whatever that means in 10 years.
Very cool. I think that is a great place to leave off here. I want to thank everyone for joining, especially our guests, Daniel, Alana, and Rand. Really excited to share the second episode of unit testing with you guys. As Rand mentioned, we're going to keep doing this, more topics at the intersection of deep tech coming down the pike. So stay tuned and interact with us and follow us on socials. Pretty active on Twitter and LinkedIn. And of course, this has been recorded, so I'm going to chop up the video, edit it, and share it as well. If you ever want to go back and take a look at it, it will be publicly available. So thanks again, and I hope everyone has a good weekend. Rand has one more thing to say, it sounds like.
I was just going to say, I think an hour might be cutting it short for those things, for those unit testing episodes, because I see there's like a bunch of questions. So maybe next time we'll put a little bit more time so that people have enough time to interact and everything. Like I still have like a zillion things to talk about, but
yeah, that's a good point. We will take that feedback and incorporate it in the next episode.
All right, thank you everyone for joining. See you soon.
Thanks a lot.
Thanks so much.
Have a great weekend. Take care.